Hello everybody, my name is Wojciech Pietrow. I'm product manager of network security in Bakotech. I'm responsible for Corero, which is a very important part of our strategy because it is one of very important player in DDoS protections world. Today we would like to show you DDoS protection in a world where every second counts. In our current time, the internet looks like a Formula One race. Everything happens very quickly, and 1 second is a huge amount of time. So 1 second in internet availability of service is so important. Let's back to the race. Only 79 seconds and 6 position divide in the last race Hamilton and Vettel. 1 point in Formula One is average about 740,000 euros. So it says that 79 seconds cost Ferrari, which was on the 6th position, almost 20 million euro. So Corero Network Security is a vendor which is located in USA, in Marlborough. Right now they are providing more than 100 active installations across many countries, so many verticals worldwide. They are operating, they have 500 active customers. Corero provides the first line on defense against DDoS and other cyber threats. Our products and services protect and optimize your critical infrastructures and online services. Our first line of defense solutions are operated for hosting providers, for data centers, internet service providers, and large enterprises. Where we can win. The best target for Corero are customers with connections more than 10 gigs of connections, or multiple 1 gig connections. And the perfect idea is solutions for banking, financial services, insurance, healthcare, government, software as a service, hosters, data centers protections, of course, media critical national infrastructures, ISPs, online gaming, and of course card payment. In many situations, customers which own only 1 gig are not target for us because low dependency on internet, no cost effective to address, unless strategic opportunity. For many customers, it's worth to pay attention to GTT. GTT Communications Incorporation, formerly Global Telecom Technology, is a multinational telecommunications and internet providers company. This company operates on a core level of internet. Frankly speaking, they are connecting country. They are connecting each main routers. What is DDoS and what is the impact? So DDoS is distributed denial of services. Attack happened when the multiple systems flood the bandwidth of resources of targeted systems, usually one of more websites. Such an attack is often the result of multiple compromised systems. For example, a botnet flooding the targeted system with traffic. When services are no longer available, it causes a huge impact to the critical services. Customers can lose the profits. DDoS attack has impact for a brand awareness. Customers, frankly speaking, are unhappy when can't log into the important pages like banks, healthcare systems, online shoppings, and many more. Because of the reputation where the DDoS attacks happened, everywhere where the vulnerability are really important. It can take off the critical services. Important play is political motivations, economic gain, and what is really important, access to the DDoS on the black market in internet is really easy. Some young guys can buy small DDoS attacks just for $15. But we never get attacked. It's really important. So how looks the landscape of threats right now? How we can compare old world of DDoS versus new world? DDoS attacks already have a long history. The first spectacular immobilization of services took place in 2001 year and touched Yahoo. The Yahoo attack was really big. Amazon's and Dell and CNN, eBay, they feel this attack too. Please note that the volume of these attacks are still increasing. In last year, Mirai broke the terabytes barrier. Mirai was totally other kind of attack because they touched units from Internet of Things. And many of customers of Corero agreed to share their traffic analysis with the producer. From the chart, we can see that there are not many big attacks, more. I would like to say there are many small, short-lived attacks. Look carefully. Only 3 attacks are higher than 10 gigs. What does it mean? It means old world solutions, old anti-DDoS world solutions are not working for the new attacks. Why? Because the systems are based in cloud, because the scribing center should monitor, detect, and redirect only huge attacks. The system is fixed for typically more than 10 gigs of traffic, and it's really important. And these systems mostly work on demand. It means some people must look carefully for all time traffic. And in New World, significant, the number of DDoS attacks is growing every year by 50%. Main customers can be attacked 6 times per day. 70% of attacks take less than 10 minutes, and 93% of attacks are less than 5 gigs. These numbers show us how much old security systems are not effective against new attack. As we said, for a new type of attack, old systems are completely useless. Dozens of small attacks causes an effect like a big one attack. There are no detectable. Like we can see, many smaller attacks are not touched by scrubbing center. They stop traffic. So the solution is Corero, which is line rated with high performance, which is automated. It's really easy to use with rich analytics, with no downtime, always on. The systems catches anomalies even for small incidents. Why Corero? It depends. For partners, because it's a unique opportunity, offer differentiated and innovative technology, are available in CapEx and OpEx model. Of course, Corero support partners, customers by SOC. For customers like service providers, it's allowed to build scalable and creable mitigation capacity, offers a premium and the basic services, provide differentiated services. For example, for enterprises, protect against today's new world order. It's really important, and it's automated, always on mitigation. The NSS Labs report is confirmation of the high efficiency of Corero solution. Only Corero and Arbor achieve recommended rating. Corero is leader for combined security efficiencies and TCO. Everybody knows that money are really important. Corero has a highest volumetric efficiency. Portfolio is very, very simple. It's hardware and virtualized solutions, of course, are available. Virtual solutions are only for KVM and VMware. Hardware solutions are designed for different performance level. NTD 120 are for 1 gig and multiply. Of combination 1 gig, NTD 280 for 10 gigs and more. NTD 1100 is for traffic higher than 100 gigs. The architecture is very important and interesting, but in this situation, I would like to pass my voice to our engineer, which will explain you how it really works. Check.
Hello and good morning, everybody. I'm Maciej Jaglasz and I'm responsible for the Corero technical support at the Bakotech site. Just let me share my screen with you. All right. So I've prepared like 6 slides for you for today, just to take a review on the components of the Corero architecture. So we've got 3 types of physical components. The main part is a SmartWall, which is a DDoS defense mitigation system, but also we've got a hardware appliance, which is optical zero power bypass appliance. So we've got two optical ports inside, which are basically zero power, and we can plug a cable from the internet here, and a second one to our network, our internal network. What is this device doing? It just basically passes all of the traffic through this interface to the mitigation device, which comes back later on after a mitigation process back to the optical bypass appliance, which gets then to our internetwork. And in the middle of those two, we've got a central management system, which is responsible for the configuration and monitoring part of the smart walls. So yeah, as we can see here, this diagram shows us all of the connection, how those devices should be connected together. This is the most simple scenario which we can get from Corero. So basically, we've got inbound traffic connected in here, which is then passed to the mitigation device, which gets this traffic back to the optical bypass, which then gets to our internal network. So we need all of the devices connected together with a just LAN switch connect, and we need a connection to the central management system. So yeah, basically going back to the slide that Wojciech showed us a few seconds earlier, At the bottom part, we've got a hardware appliances, those green ones that we've already seen, which then passes all of the information and basically share all of the informations with a Corero CMS system, which is responsible for all of the configuration part. But if you would like to, we can also use REST API or CLI just to configure all of the devices. But the more simpler process is just to use a internet browser, because we've got a web interface available on the Corero CMS system. And bypassing CMS, those devices report directly to the analytics and reportics engine, which relies on Splunk. But don't be scared of that, because Splunk is already implemented, and the Corero owns a OEM license, which is just built into the system. Next diagram that we can see, I'll come to this back in a few minutes, but now I would like to show you, just need to log in again. All right, as we can see, we are logged into the Corero CMS system, and the first part that I would like to show is a home screen where we can get a high-level information, high-level of the overview of our system. We've got two devices connected to this CMS system. All of the systems that I'm showing you, the CMS system and SWA system, are just built by Corero, and this is the demonstration system. So as we can see, two devices in here. One of them is a bypass device. The second one is a defense device. We've got a mode for the bypass. We've got automatic mode here, which means that both devices just send heartbeats to each other, and when there's no heartbeat from a mitigation device, the bypass device turns on just the bypass mode and passes all of the traffic through the optical ports, just stops passing this traffic to the mitigation device if there's no connection between those devices. So going in more details, we've got a segments, and we need to jump in to the more detailed view, which is under network and then segments. And this is the most basic part of the configuration. As we've already seen, in the first type of the device, we've got 4 ports here, and those 4 ports are divided into 2 segments, which is basically one external and one internal link. So in one green device, which is 120 in this time, we've got 2 separate segments. And those 2 separate segments are in this one device. Then if we've got 2 devices in here, we make a cluster, which is named as web demo right now. And for this cluster, there is a defined protection profile here, which we defined in a policy section, as we can see here. As this is just a demo system, we've got just one profile created in here, and now we are going to say about the policies. So yeah, we've got a packet rules, we've got flex rules, we've got threat awareness, which I skipped in right now, and the most important part in this system is a smart rules, which rely on the machine learning technology, the AI, and they can basically divide a traffic into sections and just basically point the traffic. There's purely a DDoS attack. So all of the rules are next to each other, which means that first all of the traffic is checked by packet rules, which we can see here. And those are just pre-configured basic checks for all of the packet that looks for a not RFC compliant packets, some kind of malformed packets, or the packets that are broken or that were changed into the while they were transmitted. So basically, all of the invalid. For example, this one IP packet contains an invalid version number. We can just basically turn the action to block all of the packets that match this rule and just drop all of the packets that match all of the rules. Next thing is flex rules, when packets are, as this slide shows us, when the traffic was checked with the packet rules, it now gets to the flex rules, which are manually crafted once. We can. There's nothing, to be honest, in this demo system. There's no flex rules implemented, but we just need to basically manually craft all of the flex rules to make some more filters, and we can point a types of the traffic, of the characteristics of the traffic or the packets in here, and just basically manually craft a rule that will block something that we know that is not good for us, and we can, for example, block a zero-day threats in here. And skipping the threat awareness, let's go to the smart rules, which is the most important part of the system. We've got plenty of them already implemented. Those are on predefined defaults. As we can see, all of the flex rule, all of the smart rules relies on the threshold. But please note that this is not the threshold for entire connection. It's just a threshold for the smart rules. Yeah, basically, CMS part is all for now, and we will jump into a analytics and reporting system. What am I showing now is a overview screen where we can see if the protection is on, is everything okay with the network. We can see that we've got two devices in here. We can see a segment utilization here in percentage. So when it goes up and up, we can just basically see this data here. And for the inbound traffic, we've got a chart here, which is divided into two parts: the traffic that was blocked by our system and the traffic that was allowed. And what is very, very important in this system, with machine learning implemented, this is the only system on the market. They can basically point out what was the vector of the attack. So as we can see in, let's wait for the refresh. So as we can see, we've got a charge and reflection attack performed in last 60 minutes. We can now get to the more detailed charts, and we basically can review how this system can granularly look into traffic, analyze traffic, and how many details of the traffic we can see in here. So I'll check some of the information just to show you. Let's check SmartWall signatures here. And what we can see in those charts is link utilization. So we can basically see that most of the traffic came from the internet. We can track top source IP addresses, and we can see those two here, which are like about 100% high. We can see link utilization. We can see top source ports, so the ports that the traffic came from. The inspection control information for those connections, top destination IP addresses, and as we can see, the attack was performed to this source IP address. And as a last chart, we can see top destination port, and as I can see, the attack was performed to the 5201 port. And jumping a bit lower here, we've got a SmartRules information, all of the information about SmartRules. And what the SmartRules do is they track all of the connection with the similar signatures. So with the machine learning implemented, with all of the diagnosis and all of the granular checks, we can basically for all of the traffic, for all of the connections, we can apply filters to them. And when the threshold is matched, for example, in this situation that we can see here, there was 13 signatures matched for this traffic, and all of the traffic that has signature that is pointed here was basically discovered from the Corero as a DDoS attack, and after passing the packets per second threshold, this attack was just basically blocked. All right, so that's all from me. I think that there's nothing more for now, and thank you very much for joining this webinar, and see you on the next one.